In this module, we will introduce the surface area of combination of solids. In our day-to-day life, we come across a number of solids made up of combinations of two or more of the basic solids. Look at these pictures. The truck with a container fitted on its back carrying oil or water from one place to another. Capsule, pencil, top, letterbox. Can you guess the solids combined in this tank and capsule? These both are made of a cylinder with two hemispheres at its ends. Now guess for a pencil. Yes, pencil is the combination of a cone and cylinder. And this toy is a combination of cone and hemisphere. And this letterbox has a hemisphere on a cylinder. How do we find the surface area of such a solid? Let us take this capsule and we can see that this solid is made up of a cylinder with two hemispheres stuck at either end. If we consider the surface of a newly formed object, we would be able to see only the curved surfaces of the two hemispheres and the curved surface of the cylinder. So, the total surface area of the new solid is the sum of the curved surface areas of each of the individual parts. This gives TSA of new solid is equal to CSA of one hemisphere plus CSA of cylinder plus CSA of the other hemisphere, where TSA, CSA stand for total surface area and curved surface area respectively. Now let us consider this top. To know the surface area of the toy, which consists of the CSA of the hemisphere and the CSA of the cone, so we can say total surface area of the toy is equal to CSA of hemisphere plus CSA of cone, where CSA stands for curved surface area. Now, let us take some examples. Example: Rashid got a playing top, Lattu, as his birthday present, which surprisingly had no color on it. He wanted to color it with his crayons. The top is shaped like a cone surmounted by a hemisphere. The entire top is 5 centimeters in height and the diameter of the top is 3.5 centimeters. Find the area he has to color. Solution: the top is exactly like the one we have discussed above. So, TSA of the toy is equal to CSA of hemisphere plus CSA of cone. Now, the curved surface area of the hemisphere is equal to 2 pi r square. Here r, that is radius of hemisphere, is 3.5 by 2 centimeters. On putting values, we have 2 into 22 by 7 into 3.5 by 2 into 3.5 by 2 centimeter square. Curved surface area of cone is equal to pi RL. For this we have to find the value of slant height, for which we need the height and radius of cone. So, the height of the cone is equal to height of the top minus height or radius of the hemispherical part, that is 5 minus 3.5 by 2 centimeters, which is equal to 3.25 centimeters. So, the slant height of the cone is under root r square plus h square. Putting values, we have under root square of 3.5 by 2 plus square of 3.25. On solving, it gives 3.7 centimeters. Therefore, CSA of cone is equal to pi RL, which equals to 22 by 7 into 3.5 by 2 into 3.7 centimeter square. But the surface area of the toy is equal to CSA of hemisphere plus CSA of cone, which is equal to 2 into 22 by 7 into 3.5 by 2 into 3.5 by 2 centimeter square plus 22 by 7 into 3.5 by 2 into 3.7 centimeter square. Taking common 22 by 7 into 3.5 by 2, we have sum of 3.5 and 3.7, which is equal to 11 by 2 into 7.2, which gives 39.6 centimeter square. So, the surface area of toy is 39.6 centimeter square. Example: the decorative block shown is made of two solids, a cube and a hemisphere. The base of the block is a cube with edge 5 centimeters and the hemisphere fixed on the top has a diameter of 4.2 centimeters. Find the total surface area of the block. Solution: the total surface area of the cube is equal to 6 into edge square is equal to 6 into 5 into 5 centimeter square is equal to 150 centimeter square. Here, the part of the cube where hemisphere is attached is not included in the surface area. So, the surface area of the block is equal to TSA of cube minus base area of hemisphere plus CSA of hemisphere, which is equal to 150 minus pi r square plus 2 pi r square, which is equal to 150 plus pi r square, which is equal to 150 plus 22 by 7 into 4.2 by 2 into 4.2 by 2 centimeter square. This is equal to sum of 150 and 13.86 centimeter square, which is equal to 163.86 centimeter square. In this module, we will discuss about the volume of combination of solids. We have already discussed how to find the surface area of solids made up of combination of two basic solids. Here, we shall see how to calculate their volumes. The volume of the solid formed by joining two basic solids will actually be the sum of the volumes of the constituents. Let us see in this example. Example: Shanta runs an industry in a shed which is in the shape of a cuboid surmounted by a half cylinder. If the base of the shed is of dimension 7 meters into 15 meters and the height of the cuboidal portion is 8 meters, find the volume of air that the shed can hold. Further, suppose the machinery in the shed occupies a total space of 300 meter cube and there are 20 workers, each of whom occupy about 0.08 meter cube space on an average. Then how much air is in the shed? Solution: the volume of air inside the shed when there are no people or machinery is given by the volume of air inside the cuboid and inside the half cylinder taken together. Now, the length, breadth and height of the cuboid are 15 meters, 7 meters and 8 meters respectively. Also, the diameter of the half cylinder is 7 meters and its height is 15 meters. So, the required volume is equal to volume of the cuboid plus half volume of the cylinder, which is equal to 15 into 7 into 8 plus 1 by 2 of 22 by 7 into 7 by 2 into 7 by 2 into 15 meter cube. On solving, we have 1128.75 meter cube. Example: a juice seller was serving his customers using glasses. The inner diameter of the cylindrical glass was 5 centimeters, but the bottom of the glass had a hemispherical raised portion which reduced the capacity of the glass. If the height of the glass was 10 centimeters, find the apparent capacity of the glass and its actual capacity. So, the glass is a combination of a cylinder and a hemisphere. Solution: since the inner diameter of the glass is equal to 5 centimeters and height is equal to 10 centimeters, the apparent capacity of the glass equals to the volume of the cylinder, that is, pi r square h is equal to 3.14 into 2.5 into 2.5 into 10 centimeter cube is equal to 196.25 centimeter cube. But the actual capacity of the glass is less by the volume of the hemisphere at the base of the glass. That is, less by 2 upon 3 pi r cube, which equals to 2 upon 3 into 22 upon 7 into 2.5 into 2.5 into 2.5 centimeter cube. On solving, we have 32.71 centimeter cube. So, the actual capacity of the glass is equal to apparent capacity of the glass minus volume of the hemisphere is equal to 196.25 minus 32.71 centimeter cube is equal to 163.54 centimeter cube.
Surface area and volume of 3D solids. The length, breadth and height of a box are respectively 12 decimeter, 4 decimeter and 3 decimeter. Find the length of the greatest rod that can be put in it. Let's solve this. Length of the greatest rod which can be put in the box is equal to length of the diagonal. And we know that the formula for the length of the diagonal of a cube whose sides are A, B and C is under root A square plus B square plus C square is equal to, putting the values of A, B and C, this is equal to under root 12 square plus 4 square plus 3 square is equal to under root 144 plus 16 plus 9 equal to square root of 169 is equal to 13 decimeter. This is the answer. Let's take the next example. Two cubes each with 12 centimeter edge are joined end to end. Find the surface area of the resulting cuboid. Let's solve this. For the resulting cuboid, as we can see in the figure, length L is equal to 12 plus 12 centimeter is equal to 24 centimeter. Breadth remains same as 12 centimeter and height also remains the same as 12 centimeter. Therefore, surface area of the resulting cuboid is equal to, this is given by the formula twice of length into breadth plus breadth into height plus height into length. Putting in the values of L, B and H here, we get twice of 24 into 12 plus 12 into 12 plus 12 into 24 is equal to twice of 288 plus 144 plus 288 is equal to twice of 720 is equal to 1440 centimeters square. So the surface area of the resulting cuboid is 1440 centimeters square. Let's take the next example. A go down measures 40 meter into 25 meter into 10 meter. Find the maximum number of wooden crates, each measuring 1.0 meter into 1.25 meter into 0.5 meter that can be stored in the go down. Let's solve this. Dimensions of the go down are 40 meter into 25 meter into 10 meter. Therefore, volume of the go down will be given by 40 into 25 into 10 meter cube is equal to 10,000 meter cube. As given in the question, dimensions of each crate are 1.0 meter into 1.25 meter into 0.5 meter. Therefore, volume of one crate will be given by 1.0 into 1.25 into 0.5 meter cube is equal to 0.625 meter cube. Therefore, number of wooden crates that can be stored in the go down is equal to volume of the go down divided by volume of one crate is equal to 10,000 divided by 0.625 is equal to 10,000 into 1,000 divided by 625 is equal to 16,000. So, the number of wooden crates that can be stored in the go down is equal to 16,000. Let's take the next example. A rectangular tank 1.5 meter long, 88 centimeter wide, contains water to a depth of 65 centimeter. The water is transferred to an empty tank 2 meter long, 1 meter wide. Find the depth of the water. Let's solve this. Let the depth of the water be 8 centimeter. Then the volume of water in one tank is equal to the volume of the water in the other tank. Therefore, volume of the empty tank is 200, converting 2 meter into centimeters, into 100, converting 1 meter into centimeters, into H, is equal to volume of the filled tank, converting 1.5 meter into centimeter, we get 150 centimeters into 88 into 65. From here, we can calculate the value of H. H is equal to 150 into 88 into 65 divided by 200 into 100 is equal to 42.9 centimeter. Therefore, the depth of water is 42.9 centimeter. Let's take the next example. A river 3 meter deep and 40 meter wide is flowing at the rate of 2 kilometers per hour. How much water will fall into the sea in a minute? Let's solve this. The column of water falling into the sea in 1 minute is a cuboid. Volume of water falling into the sea in 1 minute is equal to volume of water column flowing from a cuboid whose width is equal to 40 meter, depth equal to 3 meter and length is equal to length of water flowing in 1 minute. This is equal to 2000, converting 2 kilometers into meters, divided by 60, converting 1 hour into minutes. So this is 2000 by 60 meters equal to 100 by 3 meters on simplification. So, volume of water falling into the sea in 1 minute is equal to LBH, this is the formula for the volume of a cuboid, is equal to 100 by 3 into 40 into 3 meter cube, which comes out as 4000 meter cube. Let's take the next example. A solid cube of side 12 cm is cut into 8 cubes of equal volume. What will be the side of the new cube? Also find the ratio between their surface areas. Let's solve this. Let the side of the new cube be x centimeters. Then, volume of the new cube is equal to x cube centimeter cube. Volume of 8 such new cubes is equal to 8x cube centimeter cube. Volume of the cube from which these cubes are cut is equal to 12 cube centimeter cube is equal to 12 into 12 into 12 centimeter cube is equal to, this comes out to be 1728 centimeter cube. Now we know that volume of the 8 new cubes is equal to volume of the cube from which they are cut. So, this implies 8x cube is equal to 1728. This implies x cube is equal to 1728 divided by 8 is equal to 216. This implies x is equal to cube root of 216 equal to cube root of 6 into 6 into 6. This implies x is equal to 6. Therefore, side of the new cube is equal to 6 centimeter. Now, surface area of the big cube is equal to, we know the formula for the surface area of a cube is 6a square is equal to 6 into 12 square, this is given in the question, centimeter square. This is equal to 6 into 144 centimeters square is equal to 864 centimeters square. Surface area of the new cube is equal to 6 into 6 square centimeters square is equal to 6 into 36 centimeters square is equal to 216 centimeters square. Therefore, ratio between their surface areas is equal to surface area of the big cube divided by surface area of the new cube is equal to 864 divided by 216 is equal to 4 by 1 is equal to 4:1. Volume of circular cylinder. Let's take an example. The volume of a cylinder is 448 pi centimeter cube and height 7 centimeter. Find its lateral surface area and total surface area. Let's solve this. Let the radius of the cylinder be r centimeter. It is given that height h is equal to 7 centimeter and volume V is equal to 448 pi centimeter cube. Now, volume is equal to, we know the formula is pi r square h. This implies 448 pi is equal to pi r square into 7. This implies from here r square is equal to 448 pi by 7 pi is equal to 64. Taking square root on both sides, this implies that r is equal to 8 centimeter. Therefore, lateral surface area is given by the formula 2 pi rh. Putting in the values here, 2 into 22 by 7, this is the value of pi, into r, which we have calculated as 8 into 7 centimeters square. This comes out as 352 centimeters square. Total surface area will be 2 pi rh plus 2 pi r square is equal to, taking 2 pi r common inside the bracket, we will have h plus r is equal to, putting in the values here, 2 into 22 by 7, this is the value of pi, into putting the value of r is 8, into 7 plus 8 centimeters square. This comes as 5280 by 7 centimeters square, which is equal to, correct to 2 decimal places, 754.29 centimeters square. This is the total surface area. Let's take the next example. The difference between the outside and inside surfaces of a cylindrical metal pipe 14 cm long is 44 cm square. If the pipe is made of 99 cubic centimeter of metal, find the outer and inner radii of the pipe. Let's solve this. Let the external radius be capital R and internal radius small r centimeter. Height h is equal to 14 centimeter. Then, outside surface is equal to 2 pi capital RH is equal to 2 into 22 by 7 into capital R into 14 centimeters square. On calculation, this comes as 88 capital R centimeters square. Inner surface is equal to 2 pi small r h is equal to 2 into 22 by 7 into small r into 14 centimeters square is equal to 88 small r centimeters square. It is given in the question that 88 capital R minus 88 small r is equal to 44. This is the difference between the outside and inside surfaces of a cylindrical metal pipe. From here, capital R minus small r is equal to 44 by 88. This is equal to 1 by 2. Call this as first. It is given in the question that volume of metal is equal to 99 centimeter cube. Therefore, volume of metal in the pipe is equal to pi capital R square minus small r square into h is equal to 99. This implies putting 22 by 7 for pi into capital R square minus small r square into 14, h is 14, is equal to 99. This implies capital R square minus small r square is equal to 99 into 7 divided by 22 into 14 is equal to 9 by 4. This implies for capital R square minus small r square we can write capital R plus small r into capital R minus small r is equal to 9 by 4. This implies putting the value of capital R minus small r using first, capital R plus small r into 1 by 2 is equal to 9 by 4. This implies capital R plus small r is equal to 9 by 4 into 2 is equal to 9 by 2. Call this as second. Adding first and second, we will get minus small r and plus small r will get cancelled. Twice r is equal to 5. This implies capital R is equal to 5 by 2 is equal to 2.5 centimeter. Put capital R is equal to 5 by 2 in second, we get 5 by 2 plus small r is equal to 9 by 2. This implies small r is equal to 9 by 2 minus 5 by 2 is equal to 2 centimeter. Hence, external radius is 2.5 centimeter and internal radius is 2 centimeter. Let's take the next example. A copper wire of diameter 8 mm is evenly wrapped on a cylinder of length 24 cm and diameter 49 cm to cover the whole surface. Find first the length, second the volume of the wire, third weight of wire if specific gravity of copper is 8.88 grams per cubic meter. Let's solve this. Thickness of the wire is equal to diameter is equal to 8 mm. Converting this into centimeters is equal to 0.8 centimeter. Length of the cylinder is equal to 24 centimeter. This is given. Number of turns will be equal to length of cylinder divided by diameter of wire is equal to 24 by 0.8 is equal to 13. Diameter of the cylinder is 49 centimeter. This implies radius is equal to 49 by 2 centimeter. Therefore, circumference is equal to 2 pi r is equal to, putting the values, 2 into 22 by 7 into 49 by 2 centimeter is equal to 154 centimeter. This implies length of wire wrapped in one round is equal to circumference of the cylinder, which has been calculated as 154 centimeter. Therefore, total length of wire wrapped in 30 turns is equal to 30 into 154 is equal to 4620 centimeter. Radius of the wire is equal to 0.8 divided by 2 is equal to 0.4 centimeter. Therefore, volume of the wire will be given by the formula of volume of the cylinder is equal to pi r square h is equal to 22 by 7, putting 0.4 in place of r. So this becomes 22 by 7 into 0.4 into 0.4 into 4620 centimeter cube is equal to 2323.2 centimeter cube. Therefore, weight of the wire is equal to volume into density is equal to 2323.2 into 8.88 grams, which when calculated comes out as 20,630.016 grams is equal to 20,630.016 divided by 1000 kg, which is equal to 20.630 kg approximately. Important point to note here is weight of unit volume is called the specific gravity of the material. Conversion and combination of solid objects. Let's take the next example. A metal container is in the form of a right cylinder surmounted by a hemisphere of the same radius. The internal height of the cylinder is 7 meter and internal radius is 3.5 meter. Calculate first the total area of the internal surface excluding the base and second the internal volume of the container in meter cube. Take pi equal to 22 by 7. Let's solve this. For the cylindrical part, r is equal to 35 meter and h is equal to 7 meters. For the hemispherical part, r is equal to 35 meters. First, total surface area is equal to curved surface area of the cylindrical part plus curved surface area of the hemispherical part. This is equal to 2 pi r h plus 1 by 2 into 4 pi r square is equal to, putting the values, 2 into 22 by 7 into 7 by 2 into 7 plus 2 into 22 by 7 into 7 by 2 whole square meter square. This is equal to 22 into 7 plus 11 into 7 meter square is equal to 231 meter square. Second, volume of the container is equal to volume of the cylindrical part plus volume of the hemispherical part. This is equal to pi r square h plus 1 by 2 into 4 by 3 pi r cube is equal to 22 by 7 into 7 by 2 whole square into 7 plus 2 by 3 into 22 by 7 into 7 by 2 whole cube meter cube. This is equal to 11 into 49 by 2 plus 11 into 49 by 6 meter cube is equal to 11 into 49 into 2 by 3 meter cube is equal to 359 1 by 3 meter cube. Let's take the next example. A cylinder whose height is equal to its diameter has the same volume as a sphere of radius 4 cm. Calculate the radius of the base of a cylinder correct to 1 decimal place. Let's solve this. The volume of the sphere is equal to 4 by 3 pi r cube is equal to 4 by 3 into 22 by 7 into 4 cube centimeter cube. The volume of the cylinder is equal to pi r square h is equal to pi r square into 2r, because h is equal to 2r, is equal to 22 by 7 into 2 into r cube. From the equation, 22 by 7 into 2 into r cube is equal to 4 by 3 into 22 by 7 into 4 cube, or 2r cube is equal to 4 by 3 into 4 cube. This implies r cube is equal to 2 by 3 4 cube is equal to 2 to the power 7 by 3. Therefore, taking logs on both sides, log r cube is equal to log 2 to the power 7 by 3. This implies thrice log r is equal to 7 log 2 minus log 3 is equal to 7 into 0.3010 minus 0.4771. Or log r is equal to 1 by 3 into 2.1070 minus 0.4771 is equal to 1 by 3 into 1.6299 is equal to 0.5433. Therefore, r antilog is equal to 0.5433 is equal to 3.45 is equal to 3.5 correct to 1 decimal place. Therefore, the radius of the base of the cylinder is equal to 3.5 centimeter. Examples of sphere. Let's take an example. The internal and external radii of a hemispherical metallic vessel are 7 cm and 10.5 cm respectively. If 1 centimeter cube of the metal weighs 10 gram, find A. the total surface area, B. the weight of the vessel. Let's solve this. A. the total surface area is equal to internal surface area plus external surface area plus area of the circular ring at the top. This is equal to 1 by 2 into 4 pi small r square plus 1 by 2 into 4 pi capital R square plus pi into capital R square minus small r square. This is equal to, taking 2 pi common, inside the bracket we have capital R square plus small r square plus pi into capital R square minus small r square is equal to 3 pi capital R square plus pi into small r square. This is equal to 3 into 22 by 7 into 21 by 2 square plus 22 by 7 into 7 square centimeter square. This is equal to 33 into 63 by 2 plus 154 centimeter square, which on simplification comes as 1039.5 plus 154 centimeter square is equal to 1.1935 centimeter square. B. Volume of the vessel is equal to 1 by 2 into 4 by 3 pi capital R cube minus small r cube is equal to 2 by 3 into 22 by 7, 21 by 2 whole cube minus 7 cube centimeter cube is equal to 44 into 21 squared by 8 minus 49 by 3 centimeter cube is equal to 44 into 931 by 24 centimeter cube is equal to 10,241 by 6 centimeter cube. Therefore, weight of the vessel is equal to 10,241 by 6 into 10 grams is equal to 10,241 into 10 divided by 6 into 1,000 kilogram is equal to 17.07 kilograms. Let's take the next example. The ratio of the radii of two spheres is 3:2. Find the ratio of their A. Volumes, B. Surface areas. Let's solve this. Let the radii be capital R and small r. Then capital R is to small r is equal to 3:2. This implies capital R by small r is equal to 3 by 2. This implies capital R is equal to 3 by 2 small r. A. Let the volumes be capital V and small v. Then capital V is equal to 4 by 3 pi capital R cube and small v is equal to 4 by 3 pi small r cube. Capital V by small v is equal to 4 by 3 pi capital R cube by 4 by 3 pi small r cube is equal to capital R cube by small r cube is equal to 3 by 2 small r cube divided by small r cube is equal to 3 by 2 whole cube is equal to 27 by 8. Therefore, capital V is to small v is equal to 27:8. B. Let the surface area be capital S and small s. Then capital S is equal to 4 pi capital R square and small s is equal to 4 pi small r square. Therefore, capital S by small s is equal to 4 pi capital R square by 4 pi small r square is equal to capital R square by small r square is equal to 3 small r by 2 whole square divided by small r square is equal to 3 by 2 whole square is equal to 9 by 4. Therefore, capital S is to small s is equal to 9:4. Let's take the next example. A necklace contains 24 spherical beads of silver, each having a radius of 0.5 centimeter. The beads are to be coated with gold. If the cost of coating is ₹10 per centimeter square, find the total cost to the nearest rupee for coating the beads of the necklace. Let's solve this. The surface area of a bead is equal to 4 pi r square is equal to 4 into 22 by 7 into 1 by 2 whole square centimeter square. Therefore, the total surface area of 24 beads is equal to 24 into 4 into 22 by 7 into 1 by 2 whole square centimeter square. Therefore, the required cost is equal to ₹10 into 24 into 4 into 22 by 7 into 1 by 2 whole square is equal to ₹5,280 divided by 7 is equal to ₹754. 2 by 7 is equal to ₹754 rounded off to the nearest rupee. Right circular cone. Let's take an example. The ratio of the radii of two right circular cones of the same height is 1:2. Find the ratio of their 1. Volumes, two curved surface areas when the height of each cone is 3 times the smaller radius. Let's solve this. Let the radii be small r and capital R respectively, and let h be the height of each cone. From the question, small r by capital R is equal to 1 by 2. This implies capital R is equal to twice small r. First, let the volumes be small v and capital V respectively. Then, small v is equal to 1 by 3 pi small r square h and capital V is equal to 1 by 3 pi capital R square h is equal to 1 by 3 pi twice small r whole square h is equal to 4 into 1 by 3 pi small r square h is equal to 4 times small v. Therefore, small v by capital V is equal to small v by 4 into small v is equal to 1 by 4. This implies small v is to capital V is equal to 1 is to 4. Second, let the curved surface area be small s and capital S respectively. Here, h is equal to 3 times small r and capital R is equal to 2 times small r. Then, small s is equal to pi into small r into L is equal to pi into small r under root of h square plus small r square is equal to pi into small r under root of 3 into small r whole square plus small r square is equal to pi into under root of 10 small r square. Again, capital S is equal to pi into capital R into capital L. This is equal to pi into 2 into small r under root of h square plus capital R square is equal to pi into 2 into small r under root of 3 into small r whole square plus 2 into small r whole square is equal to 2 pi small r root 13 into small r is equal to 2 pi 13 small r square. Therefore, small s by capital S is equal to pi root 10 small r square divided by 2 pi root 13 small r square is equal to root 10 by 2 root 13. Therefore, small s is to capital S is equal to root 10 is to 2 root 13. Let's take the next example. The volume of a conical tent is 1232 meter cube and the area of the base floor is 154 meters square. Find the canvas required to make the tent. Take pi equal to 22 by 7. Let's solve this. The area of the base is equal to pi r square. This implies 154 meters square is equal to 22 by 7 r square. Therefore, r square is equal to 154 into 7 by 22 meters square. This implies r is equal to 7 meter. The volume of the tent is 1 by 3 pi r squared h. Therefore, 1232 meter cube is equal to 1 by 3 into 22 by 7 into 7 square into h. Therefore, h is equal to 1232 into 3 divided by 22 into 7 meters. This is equal to 8 into 3 meters is equal to 24 meter. Therefore, L is equal to under root of h square plus r square is equal to under root of 24 square plus 7 square meter. This is equal to under root of 576 plus 49 meter is equal to under root 625 meter is equal to 25 meter. Now, the required canvas is equal to area of the curved surface is equal to pi RL is equal to 22 by 7 into 7 into 25 meters square is equal to 550 meters square.